Code please.
Welcome to Code Please. In this channel, I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. Besides the basic types we have explored a little bit before, Elixir provides us with more complex data structures like maps, tuples, and keyword lists. This video attempts to explain those types and provide some tips on how and when they might be used, as well as ways to manipulate them. Maps are akin to a dictionary. You can think about it like a way to do fast lookups of connected information. The basic idea is that you have a bunch of keys, each connected to a value. Keys can be strings or atoms, and values can be anything else, including other maps or other complex structures like we discussed before. Let's take a look at some examples of maps. Let's create an example map so we can play around with it. So let's say I have a map called map. I'll just assign it to this variable named map. And the syntax for creating maps is like this, where you specify characters and then you specify the keys and values that you want inside. So a basic map that you could have is, say, the key A maps to the string foo, and then you have another key and maps to bar. So a couple of strings in this map. And the way we can reference the information inside this map, there's a few ways. So let's say we want to put a new key into this map. One way we can do it is using the map.put function, which takes our map, we name map, and then we can say, let's put the key C with the value, I don't know, go with red because I like red. And then what we get back is a new map with A, B, and C keys and with the appropriate values. So say we want to transform this map into a new map that only contains the B key, for instance. We can use another function that belongs to this special module map that is dedicated to functions that handle maps, basically. And we can use the take function, for instance, where we pass a list of keys that we want to take from our map. And let's say I just want the B key. Obviously, I forgot to pass the map that I want in the first. So what I get back is a map with only the B key. So another thing we can do is instantiate a new map from a list, for instance. So say we have a list of tuples. So it's basically a keyword list, if you were paying attention earlier. And let's say we have A and blue. Let's use colors now. And I have another tuple with B and yellow. So I assign this to my, let's say, keyword list variable. And if I pass this into map.new, which is one of the things that map.new can accept, by the way, but there are more, you get back a new map with exactly the same keys that you defined the keyword list with. This is especially useful when you want to do some data transformations on a map. Say we have, let's assign this to map again. And let's say we want to modify blue to red on the A key, for instance. One way we can do this is we can do enum.map, which is another module that handles enumerables. And this will basically transform an enumerable into something else by iterating its keys and values. So we could map this map using a function, an inline function. And one of the ways we can do this is, like, when we're iterating a map, we can iterate it based on tuples, like a keyword list. So we could do like key value, and then we could say if key equals A, we can return A and red, else we just return the same thing. So we can actually use the variables here. So we can just return this. Then if we close this, we basically modified our A value from blue to red because we are mapping this map, which is kind of funny, but we're mapping this map into something else. We're kind of morphing it dynamically by iterating all its components. Regarding map access, we can access the values in a map like so. So we still have our map. Let's say we want the value for A. We can do map.a. So we can query this value by using the dot operator. We can also use the square brackets operator. They are basically equivalent. And by the way, the map dot trick only works because the key is an atom. So let's say we had a different kind of map, say map2 equals, and this time we had strings instead. So blue, I'll just create one entry because it's enough for our purposes. If I do map2 dot a, this is no longer going to work because the atom doesn't exist, and this shortcut only works for atoms. But this one still does. Like the key now is a string A, so I can just access it via the key. And that's it for maps for now. There's a lot more to cover, and I will probably come back to this, especially when we talk about pattern matching structures, which is a very powerful concept in Elixir. We'll probably get back to some more map goodies. Tuples are useful for function returns or any other semantic meaning comparison. Very useful for pattern matching, for instance, and to control the flow of information across your application. Let's see some examples. So, like we've seen before, tuples are no more than basically a bunch of values together between curly braces. So, let's say this is a perfectly valid tuple. It evaluates, but where tuples really shine is actually in controlling the flow of our code. And one pattern you're going to see over and over in Elixir programs is the pattern OK and then some object, and also error, and let's say some string with an error, or it could also be an atom. But basically, this pattern of having OK and then something else, an error and something else, this is extremely useful to control the flow of information across our applications. And one example we can see up here is I created this simple module that internally allows us to sum two numbers, to add two numbers together, and then there's a function that calculates whether or not this a particular number is even or odd. And in the case that this value is even, I am returning OK, and I'm returning the value that I passed into my function. And on the other hand, if the value turns out to be odd, I return a tuple error, and then I use this, let's say, error code is odd. And then I have my main function, where I accept two values into this function. I add them together, and then I make a case statement. And a case statement allows me to evaluate the result of whatever I have here. And what I have here is calling this other function, asking whether or not the result is even. And since we defined this function like so, we already know that this function can return one of two things. It either returns OK and the value that we passed in, because remember we are returning the value here. And in that case, I just want to print out that same value. Everything went fine. And the other condition is if the value is not even, or if it's odd, then I return the tuple error and is odd. And in this case, I just want to print a string with this error in particular interpolated into the string. And you can see how this, being compound across your application, allows you to structure the flow of information very, very easily. And you can imagine that I could have more special cases here and return different things here, different tuples, and I could always like pattern match here against this. So if I evaluate this code and then I try to do like my module.run and I run it with a result that we know is going to be even, for instance, like 1 + 1, I get 2. But if I do a result that it's going to be odd, I actually get this value here. And the cool thing is, because of the power of pattern matching, and we're later going to see a few more examples, especially with around maps and lists, we could just add a new clause here where we match against a particular value. Let's say, for instance, the value 6. Okay, and in this case, I'll just say, okay, magic number, because I really like the number 6. And order is important when you're matching two similar clauses, because Elixir's pattern matching works top-bottom. So what Elixir is going to do is like calculates the result, and then it's going to say, okay, what's the case that's going to match this value that returns from here? And if it matches this, it shows matching number. And if it matches this, it assigns whatever comes from the value from here into value. But if we replace this, then the first sentence would never match, because it would always match against the value. This will make sense. This will make more sense as we move along. But for now, trust me, the order is important here in the case, and you need to add the more specific cases up top. I just reevaluated this, and now if I just go my module dot run, and we already know that 1 and 3 is even, so it's valid. And if we do 2 and 3, we should get the error. And then if we do 3 and 3, we should get the magic number. So you can see that tuples are very good for controlling the flow of information across applications, and this is a pattern that you see a lot in the Elixir community. Keyword lists are called that because they are basically lists made of keywords. And a keyword is nothing more than a tuple with two elements, an atom and a value. Let's explore some examples using keyword lists. Keyword lists, as we explored a little bit before while looking at maps, are basically lists made of tuples. And let's see an example. So let's say we have a same example as before, a foo, and then b bar, and we assign this to a keyword list variable. So this at first glance is very similar to a map. There are a couple of differences though. Order matters in this in keyword lists and not in maps. Maps, it's a random order. It doesn't really matter because you can access by key basically. You can also iterate, but here you have the assurance that the order matters in this case in the keyword lists. And keyword lists also can have repetition. So I can instantiate a keyword list that looks like this, and it has a completely separate value for B, and I have two B keys, quote unquote. They're not keys because each of these sets of key value are two separate items. So you can have repetition, but if you try to do map.new with this, then you get just the last value that B equated to. So basically Elixir starts going through, okay, I want to create a map where A equals foo, and then B equals bar, and then B equals green again. Okay, so B equals green, because maps cannot have repetition. It takes the last value that it figured out. So these are the couple of differences that you have between keyword lists and maps. And keyword lists are more optimized for sequential reading, and maps are more optimized for random lookups of keys. One other thing that you can do, being lists, you can say get the first element by pattern matching like head and let's say the rest of our list, because it is a list, and you can equate this to QL. And then what this will do is it will assign the first element to head. So the tuple a foo is going to be the first element of the list. And if we were to look at rest, I actually made it underscore because most of the times you don't care about the rest of the list. You're just querying for the first element. But anyways, you see that the rest of the list becomes the list without the first element. So this is another thing that differentiates maps and lists, is that you can do this kind of operations. And you can see that if you try to do the same thing it will just not work with the map because, well, a map is not a list, and Elixir knows this, so it cannot pattern match, cannot assign a map to a list inside the list. It doesn't fit. Kind of like you have two Lego pieces that just don't fit. The structure doesn't match, so Elixir gives up. And this, you could see, it's already an example of how pattern matching can work on Elixir. You can do very complex pattern matching depending on the information that you want to retrieve. So let's say I want to retrieve the value. So let's see, we had our map being A is blue and B is yellow. So let's say I want to get just the yellow value from this map. I don't need to use functions. I can just use pattern matching. So I could just say, okay, let's say this is the value I want, and I want to assign it to a variable named value. I can just do this. And what this will do is it will try to fit map into this structure that I have. And since it fits, because the map does have a key named B, and it does have a value associated with it, what Elixir will do is it will basically match the yellow value into the value variable. So if I do this, I get the map in return because that's the value that is printing. But now if I evaluate what I get in value, I did get the yellow. So, and this works for very nested structures, and it's super powerful for you to be able to understand what is coming back without having to do a bunch of if statements like you do in most other languages. So in typically in other languages you would do something like, okay, I want to see if let's say map.p equals yellow. I want to say io.puts yes, otherwise I'm gonna say no. And I get yes because map.p is obviously yellow. But if I did just this, I could instantly know if this is true or not, because Elixir would not pattern match if this was not true. So if I try to say B is blue, which is not, blue is in the A key if you notice above, it will fail because it will not match. So this is very powerful for you to understand kind of the structure that you are trying to accomplish. And this will become more and more apparent as we move forward with more complex examples. So pattern matching is a very powerful concept in Elixir. So that's it for this video. I have some links in the description if you want to know more about types and pattern matching in Elixir. And I'll see you on the next one. If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.